All right, let's take a look at section 4.6 on Norton's theorem. So Norton's theorem is similar to Thevenin's theorem in that we can take a linear circuit that's attached to a load and find an equivalent circuit. Except in Norton's, we're going to find an equivalent current source in parallel with a resistor, and that will provide the same voltage and current to the load. Now, if you think back a few sections ago, we did source transformations. So Norton and Thevenin are just source transformations to each other. Because if I do a source transformation on a Norton equivalent, what I get is a Thevenin equivalent. So if you can find Thevenin, you can find Norton. If you can find Norton, you can find Thevenin. So that's one really great thing about this section is it all goes together and transfers. It doesn't matter which one you find first. You can find the Norton values to use those to find Thevenin or vice versa. It's going to give you the same thing. So remember, in a source transformation, this R stays the same. So that means that R Thevenin is equal to R Norton, and we're going to find it in the exact same way that we found R Thevenin. That then tells us that V Thevenin, V equals IR, is I Norton times R Thevenin, or R Norton, since they're the same exact thing. So we can go back and forth between the two this way. One thing we haven't talked about yet is what to do if we have dependent sources in our linear circuit. So if we have a dependent source in linear circuit, we have a couple different options. So with Thevenin and Norton, there are a lot of options on how to find them, which way to go, directions. Some people that really stresses them out because they want one way to solve things. We have multiple ways here, so you have to do what works best, makes most sense for you. Dependent source in linear circuit. Well, for this one, one of the easy ways to do it is to turn off or deactivate independent sources and add a test voltage or current to load. What do we mean by that? Okay, so if we have our linear circuit, and I should say this is for finding the resistance. So finding R Thevenin or R Norton when there's a dependent source. So we have our linear circuit. We're going to turn off all our sources. I want them to be 0. And at our load, we're going to add a test voltage. I did not mean to draw that. I think I'm getting a little tired today. A test voltage or a test current. So let's add a test voltage. So this test voltage can be any value you want it to be. Obviously, what's a really convenient value to pick? Well, 0 would be great, but that wouldn't get us anywhere. So we can select our VT to be 1 volt. That's easy to work with. You can select that and then find IT. Using that, your R Thevenin will then be VT over IT. The other way to do this is to add a test current out here. So just a current source instead, and in that case, this is OR. You can select your IT to be something convenient like 1 amp, and then find your VT. It doesn't matter which way you do it, whatever you're more comfortable with. I tend to add the test voltage. I don't know why, I just like that. But we'll work an example of that in the next video.